I'll think of a way to share it with everyone later. Okay, it's now recording. Yeah. So, question 1, part A. In the interval scheduling problem, shorten the intervals by increasing number of conflicts instead of increasing finish time would still give us the optimal solution. True or false? Quickly in the chat, type it down. If you think it's true, if you think it's false. Yep, it is false. Justification, if it's true, Vassos would have put it in the lecture. Just kidding. You can try to make a counterexample where it will be forced to make wrong selections. So something like this can work. Can we refer to proofs in lecture? Yes, you can. But you're putting yourself in a more difficult situation. If your proof is lacking in some sense, you might get dot marks for it. But if it's a counterexample, yeah, you get it directly. Will this recording be posted? What I have in mind is to have a Google Forms. Then I will share some kind of Google Drive with you guys. What if we forget what the interval scheduling problem is during the exam? That's why you have a cheat sheet. Yeah, we can post it on YouTube. I'll just like put the link somewhere. Because I didn't ask Vassos directly if I could record this part. Okay. He doesn't need to know. Okay, fair. Let's move on. Let's probably answer directly. In the minimum lateness scheduling problem, if all jobs have the same deadline, there is no need to sort the jobs in any particular order before greedily scheduling them, as any order will produce an optimal solution with the minimum maximum lateness. True or false? We have some true, we have some false. Okay, it's interesting. The length can differ. There's no real specification about the length. It's just that they all have the same deadline. So the answer is, it's true. Even if the deadline is really far or the deadline is really close. Yep, Zubair said it best. The finish time of the last job in any order would be the sum of all the time for every job to finish. Because the deadline is the same for all jobs, the max lateness would always be the summation of t minus the deadline. Yep. Okay. Any questions about this one?
What is this sum mean? Can it be more specific?
The sum, like this one?
Yes.
Oh, so I'll
What
just
is the
open.
restriction for I?
Oh, the I is just the range of all the jobs that you have.
Uh,
So
not sure what that exactly.
let's open the document. That's the first week's document. So here, um, your I is for each job in any order. That's the I. So the I is just the job. Yep, it's max lateness. Because The latest would always be the same. The
So it
minimum
will be the
max it's
sum
the
of
same.
all TI for every job. I,
Yep,
right?
yep, yep.
Okay.
Okay. So the next one, the next two actually is about Huffman's. Why am I spoiling the answer already? Um, in Huffman's algorithm, if there is exactly one symbol with frequency 1/3, all other symbols, have frequency strictly less than 1/3, the algorithm may produce a code word of length 1. So may produce. So if it's true, give me an example. If it's false, you need to prove why it's false. Are these past midterm questions? No. No. It's a mix of. So this one is from your assignment 3 bonus question. Just want to make sure you all have done it. So I'll just cover it as part of this. The other ones are found from the textbook or some that I made up on my own. Okay. True. If only two symbols. You can't have only two symbols because the sum of the frequencies sum up to 1. And if one of them is exactly 1/3, yep, minimum 4 symbols. Okay, let's go through the example that I have. It's true. So we have 5 symbols, A, B, C, D, E. Let's define the frequency as 1/3 for A. That's our one symbol with exact frequency 1/3. And for the rest, define it as 1/6. And the possible output of Huffman is that it sums up the two smallest ones first. They're both 1/6. That becomes 1/3. Then it sums up the two remaining 1/6 plus 1/3. And because the keyword is may produce, you can rely on tiebreaker such that it will give this output. Is this clear?
I have a quick question.
Yep.
Does this mean that every Huffman's algorithm that has a single symbol with frequency 1/3 may produce a code word, or just there is some Huffman's algorithm that has exactly one symbol with frequency 1/3 that may produce a code word of length 1?
I think there is some. I
There
think
is some.
you can make an example. I think it's much easier to make the example where it's not
Okay.
a code word of length 1.
Okay, thank you.
No worries. Like if you can make a way where these two, you would lower the total frequency, then you would increase this one. What you would end up getting would be something like this. Yeah. Like it's deliberate why B and C have to sum up to 1/3. And these two have to sum up to 1/3 also. Where could you watch the recording? Somewhere online. I'll decide it. I'll think of a way after this meeting. Like, ideally, I only wanted to share to the attendees. We'll find a way. We'll find a way. That's why we're in CS. We find ways to problems. Okay. Any questions?
Wait, if frequency has to sum up to 1, how are we creating code word of length 1? Wouldn't we need at least 2 letters to add it to 1?
So in this case,
Oh, you're talking about the definition over
yeah.
there.
The frequency in every iteration has to sum up to 1. So like what I mean by every iteration is that let's say we select B and C first, and in the next iteration we have the options of either this one, like this whole tree. This is 1/3, 1/6, 1/6, 1/3.
Wait, but then why does the frequency or anything matter at all? Like, what is stopping us from picking just code word with any one letter? Like A is our code word or whatever.
Oh yeah, so we we want to have one of them that have frequency of 1/3, and from any of them, our job is to assign the frequencies such that one of them will have code word of length 1. Intuitively, the one that has the shortest code word will be the one with the largest frequency.
Okay.
The answer for A again, it's this one. Okay, let's move to the next question. In Huffman's algorithm, if every symbol has frequency strictly less than 1/3 now, we argue that the algorithm may still produce a code word of length 1. What if we have two symbols with frequency 1/3 and 2/3? To answer your question, it's because the constraint here is all other symbols have frequency strictly less than 1/3. Unless you mean that the other one is a 3 already, that means you didn't give the right frequency. Like what I said, it's much easier to give one that wouldn't produce a code word of length 1 than giving one that gives a code word of length 1. Okay, for this one, rapid fire, true or false?
Can we give it like a geometric series with 2 least minimum?
It's a bit of an overkill. Like, yeah, you can. That would make your argument really strong, but the point of solving this question is you want to get it, we want to solve it as quick as possible so we have enough time for the rest.
1/4, 1/8, 1/16, 1/32, stuff like that.
But then you would there's a there will be a fallacy in your argument at some point. Okay, so the answer is false. So suppose the contradiction. Suppose that there exists a set of symbols such that for all I in a set of symbols, the frequency of I is strictly less than 1/3, and our algorithm still produce a code word of length 1. Among the set, let's arbitrarily pick A or define A to be the code word of length 1. First case, our set only has two symbols. Let's say it's A and B. Then this is a contradiction because the sum of it wouldn't sum up to 1. It would be at most 2/3. Right? So this is the very simple case. The harder case is that if our set of symbols has more than size 2. So consider the second last iteration of Huffman's algorithm. So in the second last iteration, we have the options of the leaf A, leaf or 3x, and leaf or 3y. By the supposition that A has code word of length 1, that means in this iteration, Huffman picked to combine x and y. In other words, the frequency of A is more than the frequency of x, and the frequency of A is bigger than or equal to the frequency of y. Is this part clear? Yes, no, yes, yes, yes. Yes. Okay. So, however, by our supposition, we know that the frequency of all symbols is strictly less than 1/3. In other words, f of A plus f of x plus f of y, by the connection in here, this is less than or equal to f of A plus f of A plus f of A, which is strictly less than 1/3 plus 1/3 plus 1/3, which is equal to 1. Contradiction. The sum of the frequency in this iteration is not equal to 1. Is this clear? Okay, I'll take silence as a yes. Any questions about this? Our last chance. What's the first intuition to this problem? My intuition when I solved this is an assignment question for me. It's such that, think of it like this. If one of the symbols has code word of length 1, that means it's picked last, right? So it has, in every iteration, it survives the cut because it's the largest one. Think of a scenario where you would have 3 options left. The one that survives the cut is bigger than or equal to the other 2. And we know that everything is less than 1/3. So we need to highlight the fact that it violates the sum of frequencies in every iteration is equal to 1. Any tips on how to approach such questions? Oh, sorry, where can you find this PDF? It's on Piazza. It's in the announcement that I made for the midterm review seminar. And it's the one that has a hyperlink on how to approach such questions. Usually, the property that gets broken is the fact that the sum of the frequencies in every iteration is equal to 1. That's the property that's most commonly broken. And you also need to use the fact that Hoffman greedily picks 2 of the lowest frequencies. So the one that's not picked can act as an upper bound for the rest of the options in the specific iteration. But like, oh, what if we have 3 that's not picked, 2 that's picked? Which one of the 3 is the greatest? This is why I specifically highlighted the second last iteration, where we only have 3 elements left and 2 of them gets picked. So we know that this one is bigger than or equal to the other 2. Okay. Okay, let's move on. Suppose we are given an array A of n distinct elements, and we want to find n/2 elements in the array whose median is also the median of A. Any algorithm that does this must take omega n log n time. True or false? I'll highlight the key parts. Yep, it is false. Whenever there's a question that mentions median and you have some running time constraint, the first thing you have to think about is deselect. False. We can use deselect, which only takes theta n at worst. First, we find a median with deselect. This takes theta n. Partition the array around the median, then take n/4 elements from either side to get a total of n/2 elements. So all in all, this will take theta n, which is less than n log n. Okay, this one's pretty simple.
But
Okay.
we just gives out an algorithm that cannot do within n log n. How do we prove that there does not exist of any kind of algorithm.
Oh, the statement is saying any algorithm that solves this must at least take n log n.
Oh, we're taking an algorithm that is faster.
Yep, it's faster.
Okay.
If it
Yep.
wasn't, you know how like in the deselect it partitions it in groups of 5? If we partitioned it in groups of like 7 or 8, would it still be the same runtime?
It would still be the same runtime. Because you're only shifting just passing the work around, it will still be linear time.
Okay.
But I think 7 or 8. You might want to be careful with the recursive subcalls. But I think it should still be linear time. I'm sure it should still be linear time. Okay. Next. This is very similar to a common question if you've seen it in B63. If P is a shortest path from node U to node V in a directed graph with positive edge weights, then P is also the shortest path from U to V if we reduce the weight of each edge by 1. True or false? Yeah, it's false. It's a very common question you see a lot where we modify the weight of each edge. It's because in the shortest path possible, we don't take into account how many edges we take. It's just the sum of the weights of the edges. So in this case, originally, the shortest path would be this one, the one that's highlighted. And if we reduce the weight of each edge by 1, it would now be this one, bunch of zeros. Okay. This one's clear. I'll zoom out so you guys can take a picture. What if all existing edges are above 1? That's a practice question for you. It would be a bit harder to make it would make it a bit harder for the counterexample, but I'm sure it's still false. Okay. Can you show part D again? Yes, I can. A, B, C, D. Okay, 3 seconds. Okay, show previous page. Yep. Page 2 as a whole. Sorry. Okay, you're welcome. Okay, let's do the next question. So, question 2. Your manager has been assigning you tedious tasks and making your workdays unbearable. So you decide it's time for a little bit of revenge. Don't worry, it's just hypothetical. The investment company you work for has stock prices for the next n consecutive days. Each day has a fixed stock price, and you have access to all this information. Leveraging your advanced C73 knowledge, you realize that you can subtly sabotage the company's finances. The plan is to buy stocks on one day, then sell them on a later day. So this is key information. You can only sell after you buy to make the maximum loss. But there's a catch. You need to figure out the right days to buy and sell in O(n) log n time before your colleagues get a win of your plans. So the input is an array of integers where AI represents the stock price on day I. The output is the pair of days ij, where I is strictly less than j, such that buying on day I and selling on day j results in maximum possible loss. If no loss can be made, return ij with a loss of 0. So I'll give you guys 2 minutes to think about it first? Yeah, I'm sure you'll do. If you have some kind of idea in the chat and you're not sure about it, you can feel free to personally message me. I think I should have mentioned somewhere here that it has to be divide and conquer algorithm. Or else you could have just done this in O of n. Would it be O of n squared with 2 pointers? Not sure. Yeah, Robert, that's right. That's not the best talking first. Okay, let's go through the main idea for the question. So, I'll zoom in here. So we have 3 cases. The best loss is in the first half. The best loss is in the second half, or the best loss crosses both halves. The information needed to calculate I, and I is the by date of the substructure, the best cell date of the substructure, the max value in that substructure, and the min value in that substructure. And the base case would be size of 1. Okay, so the algorithm. So this is the base case. If the length of A is just 1, return 1, 1, 1, 1, 1. Let's define our splitter to be mid. Recursively call from for the left half, so from 1 to mid, label it as L by, L cell, L max, L min. Call it on the right half. This is just to adjust the index, so we add mid to everything. You would have R by, R cell, R max, R min. So the max loss from the left half is this. Do the same for the right side. And to get the loss from the cross, yeah, I can only buy and sell once. That's correct. Would be taking the minimum of the left half and taking the maximum of the right half. This should be. If your max loss is in the left half, then set the date of buy to L buy, set the date of sell to L sell. If it's the opposite, set it to R buy and R sell. If cross loss is the max loss, set it to left min and R max. Call the max for both and return everything. Can we only buy and sell once? Yes, can you do this in O of n? I'm sure some of you are smart enough to do this in O of n.
Why are we choosing the minimum of the left and maximum of the right?
This is to pass on the value to the next recursive call. We're not forced to do in DNC, guys. You're supposed to be forced to do in DNC. I should have wrote it. You're supposed to do in DNC.
But for cross loss equals to minimum of the left divide by reduced by maximum of the right, then shouldn't it be we're pursuing the maximum value of the loss instead of the minimum?
Oh, for this one? Max and min is only to store the index of the max value in that array and the index of the min value in that whole array.
Then how do we return the index of these two?
Oh,
We're
then I
looking
guess,
for ij, right? We're not
yeah,
looking for the
then
value or say the maximum loss. We're looking for the
you can have like a wrapper call that calls it on I'll be lazy and I'll call it ABCDE. No, ABCD actually. ABCD equals max loss A. The wrapper takes an A. Return by L cell. Return AB. There you go. You need to wrap the whole thing. What does max date and min date represent? It represents the date. It represents the index of the maximum value in that array and the index of the minimum value in that array. Yeah, that's O of n. O of n.
so we're actually pursuing for ON, theta n instead of n of n.
If you would have O of n, it wouldn't be divide and conquer, I think. Actually, yeah, it would be DP. I think you can have a DP algorithm with O of n.
Excuse me.
Yep.
I'm a bit confused about calculating cross loss.
Okay.
If we want to make sure that we buy at the lowest amount and then, sorry, if we buy at the highest amount and then sell at the lowest amount.
Oh, it's an opposite world. We're trying to sabotage our company. We're the bad guys here. We're trying to.
So we're trying, but buy high and sell low.
Oh yeah.
So
Max.
AMACSS and min, yeah?
Yeah.
Okay, thank you.
I got confused making up this question. Yeah. Yeah, if you can have like an idea of like a sliding window. Be theta n. Algorithm is theta n, right? Is it? Let's see. Oh, I didn't finish writing this. Why?
That was another thing I was wondering about. Since it asks for n log n, I think the max and the min thing, we don't need to do that as part of the recursion. We can do that as part of the combining stage.
Yeah. I think the simpler solution is to not pass the max and the min and do some linear time work on each recursive level.
Like we can loop through the left to find the minimum and
Yep.
loop through the right to find the maximum.
Yeah, it's actually theta n. Actually, yeah, DNC can give you theta n. Apologies.
Yeah, I think that algorithm, although it's less efficient, but it's much faster to write during the exam.
Yeah. I think you had an assignment question where you had to return multiple information and use it to combine things
But that
together.
is also of theta n, but it takes me an entire day to come up with that solution.
Yeah. Okay. Any more questions about this one? I'll zoom in so you guys can take a picture.
We get extra marks, so we get a faster algorithm.
I think this question, if it's made by Vassos and someone who actually knows how to make midterms question, it will be something like your algorithm must run in theta n for full marks. For partial credit, you can make it O n log n, something like that.
Okay.
Wait, is this theta or O? Oh,
Same
okay,
thing,
so
same thing. It's theta because we use master's theorem, but if it's in theta, then it's in O.
if it requires us to run in theta n log n, then it means it must be strictly equals to that. So we cannot use this algorithm because this algorithm will be in theta n instead
Oh
of
yeah,
theta n
yeah,
log n.
yeah, yeah. I intentionally put big O in here. I totally put it intentionally. I didn't overthink. Okay. A little bit to the right. Yes, I can. Do you need to zoom into the pseudocode like this? Okay. Let's move to the next one. Okay. Given algorithm that takes as input an unweighted directed graph G. In other words, where each node V has weight WV, each edge has 0 weight, and returns the minimum weight path from a source node to a target node T. The weight of a path is the sum of the weights of the nodes on the path, including the start and the end nodes. So this is another question where you would have to manipulate the input in some form, apply Dijkstra to it, then the result of the Dijkstra is the output that you want. I'll give you guys 3 minutes to think of some kind of reduction. So similar like what we saw in default 23 midterm, we won't be modifying Dijkstra directly. We will just be massaging the input, then feeding it to Dijkstra.
Based on the previous midterms, do you think it would be fair to assume one greedy algorithm question, one divide and conquer, one Dijkstra, and one dynamic programming?
Yeah.
Okay.
And some Hoffman questions in your true or false.
Okay. So like the named algorithm that he showed us, Huffman, Karatsuba, I think there was another one with matrix multiplication.
Strassen? Is it yours?
Strassen, yeah. Knowing that stuff is a good idea.
You should know. You should put the runtime in the cheat sheet. You should know what it solves. And I think if you look at the final exam of fall 23, there was a pretty good question about Strassen, where like you had to use Strassen in a way, or like modify Karatsuba to kind of work with matrices. I forgot the exact question. It's in the final exam. It's in the final exam.
The 2023 one?
Yep.
Okay.
Oh yeah, you could define a completely new weight function. You could complete a new graph. You just want to be careful of the runtime. Wasn't this in the tutorial? Was it? I didn't teach this week's.
No, I
Oh.
think it was something similar. I think the edges also have weights, and the nodes also have weights.
Oh wow. Oh well, I should have checked the tutorial papers. Okay, yeah. Then I'm sure most of you know the solution already. Okay, so yep, that's correct. That's the right reduction. So for each node, U and G, we create two nodes, U in and U out in G prime, and define an edge from U in to U out with weight equals to the weight of U. So in other words, if you have something like this with weight K, this is in G. In your new one, you would have U in K U out. And then for each edge, U, V, and G, create an edge from U out to V in with weight 0 in G prime. So if there's U, V, so create an edge from U out with weight 0 to V in. Then run Dijkstra from S in to T out. in G prime. Okay, is that clear? So make sure to be really comfortable with reducing or like manipulating graphs.
I'm a little confused how this would work in this scenario, given that there is no weight between, like actual edges don't have weights.
Even if the edges have weights, then you could just, it's basically the same reduction like what you see in tutorial, right? So if like, let's say this has a weight of J, you can just replace this with J.
But like, if I take my start node, for example, and I split it into two nodes, like start in and start out, and
Yep.
it has whatever the weight is. Once I remove that from my feet or from my sets, after that, all the outgoing edges are going to be 0. And
Yeah.
then we just go from there. We'd extract all the 0 edges.
Yep. So what you have to be careful in here is that because the definition of the path includes the start and the end node's weight, we want to call it from start in to make sure it goes through start out and
Yeah.
get the weight of start, and make the finish point T out to make sure you go from T in to T out and get the weight of T also.
Okay.
The weight of an edge is the average of the two nodes connecting it. I think I can make a counterexample. If your S to T is like 1, 3, and you're taking the average of the weight, this would have weight of 2, this would have weight of 4. So someone proposed in the chat of taking the average of the two nodes it's connecting. You would get half of it. Maybe you want 2 times of the average. You don't need the W. Only the path is required. Oh, is that what you mean? I still feel like you have some edge cases. If your weighing of the path is already wrong, then it's very likely the texture also will have some kind of edge case. It's also valid. WV goes to V. W. Sorry, for the person who just messaged me, can you clarify what this line means? Oops. Don't want to go to my D1 stuff. Actually, the weight being proportional. Yeah, I think the path will still be correct, but you would be able to get the correct weight. Yeah. Can we update each weight of the edge to be the sum of the weight of V and U? For the idea for summing the weight, how will I be letting you know where the recording is posted? What if I just create a Google Drive right now? Give me a second. I'll just give the link here. Okay. Welcome. The issue with making the edge defined to be the sum of the weight of the two nodes is that if you have something like this, 1, 1, 1, the weight of going from S to T in here would be 3. But if you make this weight of 2, you'll get 4. That's the issue. Oh, you're defining a function. Okay. That is a function that takes in UV, returns the node. That's something though. You might be. I think, yeah. That can also work because if we disregard the weight of the very first node in the path, that would also affect everything else. Then you're kind of shifting the value by a constant for everything. Yep. That, I think that should work. Okay, let's move on. Let's not take too much time. Oh, running time. Constructing G prime takes theta n plus m time because we have n plus m. Because we have 2n and n plus m edges in the new one. Touch on that thing takes this much time, then you can simplify it with your P63 knowledge to become theta of m plus n log n. Okay. Okay, let's do DP now. So, question 4. You are given an unlimited supply of coins of limited denominations x1 up to xn, and you wish to make change that sums up to a target value v. That is, you want to find a set of coins whose total value is exactly v. Note that it may not always be possible. For instance, if the denominations are 3, 5, and 7, you can make a change for 16. That's 2 3s and 2 5s, but not for 22. In this question, you are to develop a polynomial time dynamic programming algorithm that determines whether or not it is possible to make change for a given value v using the available denominations x1 up to xn. Okay, can someone give me the sub-problem for this DP question? Or I'll give you guys a minute first to read it and think about it. Okay. Yeah. 3, 5, 7, 7. Okay, someone had to do it. 19. I should send my 4. 4. I will send you an email of my draft for the final review seminar before publishing on Piazza next time. Okay. Okay. Yep, you can use duplicate coins. Okay, so the sub-problem for this one. Yeah, DP1 can be of type Boolean. It's like your first question in assignment 6. You can think of it like 1 and zeros. Same thing, true or false. So D of I is it possible to make a sum of I? the sub-problem would be true for I equals to 3, 5, 7, 0. Why did I use this? Why did I use this exact values? I just write and write your solutions in the morning. Is in x1, xn. If I is less than the min of x1, xn. Not set of codes. Oh yeah, if you already have the Boolean, you could just retrofit your algorithm to give you the set of coins. And for the recursive formula, it will be d of I minus x1 or d of I minus xn. Okay. Yeah. And yeah, you can, yeah, the pseudocode is a bit wrong because I made the wrong recursive formula. So yeah, there was actually a question in AC7 that finds the that's something to do with coin denominations also. It was one of the questions for your strong induction proof practice. And it's the same idea like DP in the end of the day. So you also have this is like your multiple base cases, and this is your recursive calls. Okay. So the algorithm. Since this is completely wrong, can someone in the chat give me the right algorithm for this? Okay, that's quick. Okay. Make chain of P and your sets of x1 up to xn dp equals to false, false. This is n plus 1 times dp of 0. I would say 0. I would prefer if it's 0, x1 up to xn to be true. Then, yeah, for I equals to 1, 2, you would start from max of x1 to xn plus 1, 2, 3 for xj in this set of x1 up to xn if I minus xj. I don't think we need this scenario. Because we're constraining the for loop starting index now. So we don't need that scenario. dp of I is equal to dp of I or dp of I minus xj. Return dp of v. Correct. But we can make change for 3 with 1 or 2. If we start from 5, we would get dp3 false. Wait, give me a sec. My brain is not breathing right now. If we start from 5, we would get 3. Because it would be redundant to start from something you know that's already true. That's why I added 1 to the max. 5. Oh yeah, I can post it here on Zoom. Wait. If it's 5, we would get DP3 false. But we would get DP. We would get DP1, which is true, and 1 plus 4 makes up 5. Because it's an OR. That's why the true will propagate till the end. As soon as you hit one of them as true, it will carry over till the end. Okay. So,
Sorry, quick question.
Yep.
At the beginning, when you make that whole list of falses,
Mhm.
shouldn't it be v plus 1 instead of n plus 1?
You're right. Good catch. It's all these features. V plus 1. V plus 1. Then I probably messed up the for loop. Nope, I did the for loop right. Okay. So the running time. This now takes theta n square. The double for loop. So we have the constant part and the
Because the
double.
running time of this will be v times n. That'll be dp. Sorry, MP question?
Oh yeah,
MP
yeah,
problem.
yeah. V times n is still polynomial. What non-polynomial is something like v to the power of n. That's non-polynomial.
But why is it for a discrete knapsack question? Then
Yeah, it shouldn't be polynomial on the size of the input. This is in the
Oh.
value of the input.
Yeah, what if like there's a customer
Oh
who
yeah.
want us to make change for like $1,000 of change? Although that was kind of extreme, but
Okay, yeah, pseudo polynomial. Yep. Okay. Okay. Good job spotting it out.
so cannot develop a polynomial time, right?
No.
Okay.
No. Yeah, visa generate. That's correct. Okay.
Wait, what is the difference between polynomial and pseudo polynomial?
So, so if it's just n, it would be polynomial because the size of this input is n, and the size of this input is just the size of int. So because it depends on the value of v, not the size of v, hence it's pseudo polynomial.
So by pseudo polynomial, we mean that the input size is polynomial?
Pseudo polynomial means that the running time of your algorithm depends on the value of the input, not the
Okay.
size of the input.
All right.
Yep. Okay. Okay, let's move on to the last question. So this was taken from the textbook. Hopefully there's no mistake in this one. Okay, so question 5. A contiguous subsequence of a list S is a subsequence made up of consecutive elements of S. For instance, if S is 5, 15, negative 30, yada, 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 then 15, negative 30, 10 is a contiguous subsequence, but 5, 15, and 40 is not. Give a linear time algorithm for the following task. List of numbers A1 up to AN. Output is the contiguous subsequence of maximum sum. A subsequence of length 0 has sum 0. For the preceding example, the answer would be 10, negative 5, 40, 10 with the sum of 55. In this question, you are to develop a polynomial time, actually linear time, dynamic programming algorithm that determines the contiguous subsequence of maximum sum. Okay. For this one, it can be a bit challenging because the sub problems that you will need to solve, or the sub problems that I came up with, isn't directly going to give you the answer for the original problem. Yeah, if you know cadence, then like it's basically cadence algorithm. But if you don't know it, don't Google it yet. Like think of it, try to think of it yourself. Okay. How is this different from A4 question 2? Let me open A4 question 2. This one's DP. That's divide and conquer. I need to double check the assignments next time. Oh well. Okay. Will this be faster than n? I think it will be O of n. I think it will be exactly O of n. Okay, let's go through it. Because the question wants you to practice DP. So, the idea here is that we know that any contiguous subsequence has to end at some index. Oh yeah, the question usually like outright says give me a if it asks you for a subproblem, recursive formula, pseudocode, running time, that's DP. It usually asks you for divide and conquer. For greedy, it will also ask you. For Dijkstra, they won't say it, but if it's a graph and if it's something that has to do with paths, it's Dijkstra. Like shortest paths. Okay. So among these contiguous subsequences, which one will produce the max sum? We need to get the max of each index's max. So this sounds familiar to week 5 tutorial question 2. So what I mean by that is that, so let's go to week 5. Here. So it's similar in the sense that we can think of the array, if it helps, or if it just confuses you a bit more, don't think of it like this, but we can think of the array as a graph that's more like a linked list. Okay. So our subproblem is the max sum of a contiguous subsequence ending at I. And the solution to our original problem will be the max of this one or 0. That's for the case of this one. So in here, the solution to the original problem is not a direct derivation from the subproblem, but you're taking the result of all the subproblems and doing some work on it. Okay. So give a recursive formula. If I is equal to 1, you just take A1, AI. If otherwise, you either extend the previous contiguous subsequence, or you cut it off and just do AI. That's clear?
So what is the subsequence for a sequence that only contains negative numbers?
You would end up having individual ones for each one. And when you extract the original problem, since it's like the max of that individual negatives and 0, you would get 0.
So we return empty set in that case?
Yep. That's
Okay.
that. John, yes, you can make it max 0 in AI. It just depends on how you'll do your pseudocode in the end. That's also a valid way to do it. I just like to shift the 0 to the very last step, since it made the pseudocode much simpler. Okay, so your so this part is the recursive formula. So we initialize max, initialize n, set the base case. Then for I from 2 up to n, do the recursive call. If your s of I is bigger than max, then let that be the new max. Then we extend where n is. Once we get what max is, so that's already solving this one. We already have the max. From the n, we keep on extending backwards until we captured the entire contiguous subsequence. So reversing backwards until it captures the entire sum, then we break. If the max that we get ends up being negative, it's much better to just return the empty array. Else return a start to n. So it's like you can Google Cadence algorithm. It's a modified version of that. Any questions? Okay. If not, then we can analyze the running time. Theta n, rest takes theta 1, theta n. Can we use do the practice TP question? Okay. Where did he upload this one? Okay. Let me export this document. Then we can go through the practice question Vassos posted. Never knew it made that sound. But what if the sequence to I has the maximum subsequence, excluding item I? Part of the... Oh, so in that case, because your new S of I wouldn't be bigger than max, since it cuts off over there, we wouldn't update the max nor update the n. So the n will be left in there. I'm uploading the PDF right now in the chat. Just like I shared a Google Drive just now, the recording will one way or another be accessed from there. Whether it's going to be YouTube link or like the whole video in there. Okay. Let's do the question Vassos posted.
But what about for S1 in this case?
X1
But for this,
for the solution or the Vassos practice question?
oh, never mind. We just mandatory let S1 equals to A1.
Yep. Okay, you're welcome. I'll stop the recording now, and